Hi, my name is Ryan, and if you're thinking about designing a healthy home, you're in the right place. So today I'm going to be talking to you about ventilation, in particular ventilation in homes and how to do it correctly and how certain things you need to consider when looking at designing a ventilation system for your new home. So firstly, documentation. So what documentation do you need to refer to? So the biggest one is Part F, which outlines all the minimum flow rates within your building. This covers homes and anything else as well underneath the sun, but the key thing is that it does outline minimum ventilation rates. Generally, the one you need to look at is the minimum ventilation rate for your floor area. Depending on the size of your building and what sort of size, how many toilets and kitchens you have, will depend on your minimum boost rate, but generally it is your minimum supply rate that determines your MVHR size or ventilation rate. Secondly, there's the Domestic Compliance Guide. The Domestic Ventilation Compliance Guide. In there, it's a very useful document. It outlines exactly how it should be commissioned, how it should be designed, what sort of controls should be provided, etc., etc. And then there's the Domestic Service Compliance Guide. In there, it outlines the maximum specific fan power. So effectively, it is how much energy your ventilation systems should use, or the maximum ventilation system. Please also to note that these documents outline the minimum requirements. That doesn't necessarily mean that will suit your requirements for your building. So if you've got a very intense, high populated home, that some people do have, it might be worth increasing your ventilation rates. Or if you've got certain aspects that you have, like workshops and stuff like that, it's always very important to understand that these are minimum. They do not guarantee a good, healthy environment. If in doubt, please feel free to give us a ring and we can point you in the right direction. So firstly, what ventilation types are there? Well, there's the most common one, which is the intermittent, which is probably everybody's been at least lived in a house that actually has had intermittent ventilation. I would not recommend this in any new home being built today. This is a very poor design. It's also a very cheap design, so that's why we see it very common in modern large build developments. But we've made our homes so tight that we need to have ventilation brought into the building all the time, whereas intermittent ventilation systems only really work when you're using the toilet, kitchen, and WCs. But bearing in mind, we are constantly emitting CO2 into the spaces, and also all your products are also emitting other contaminants into the air. So you need fresh air and exhaust air all the time in a house to ensure that you do have a healthy environment. And that's probably one of the main reasons why we're having studies show that these systems do not work. I appreciate that building regulations allow this to happen, because in theory you use trickle vents and you use the windows, but in reality people don't use them properly, and people will sit in a room that has a very high CO2 factor, but you won't realise that you are sitting in there unless you have indoor air quality sensors, which pretty much no new homes do have, unless you specify one. So now the next one is a constant extract unit. That is simply a single fan in your house. It could be located in a closet or a utility room or in the roof space, where it constantly sucks out air from the space, from your toilets, your kitchen, and your WCs. So you're constantly sucking air out. So the replacement air will come through natural means, inverted commas. So that will come through your windows or your trickle vents or underneath the poorly sealed doors. It is still not a great solution in a modern home. It is good in certain instances, potentially maybe refurbishments. I probably wouldn't really recommend it in most cases. The one that I recommend on most new builds is the MVHR system, which is a mechanical ventilation with a heat recovery, which is a single packaged unit which has a supply and extract fan. The supply comes from outside, passes a heat exchanger, which then supplies air into the space. The exhausting air gets extracted from places like toilets, kitchen, and WCs, that warm air then gets put over the heat exchanger and then transfers a lot of the energy from the extracting air into the supply air. So saving a lot of energy doing that. I have produced a few more videos in the series that explains this a little bit more, but we'll discuss it in a little bit. So I'm just going to show you a bit of an example of each unit. Firstly, I want to say that I use a lot of New Air products. This is because they just had a very good website, very good pictures. I am not affiliated with them in any way. There are loads of other manufacturers on the market that will do similar units. In some cases will actually do better units. Other units that I would also recommend, just because they have got a good reputation, are Vantaxia. They pretty much dominate the domestic market, and they have a very good sales team, and so does and support team. So does New Air as well. But again, I'm not affiliated. I am a professional in terms of I provide advice, and I earn my money through advice only. I do not get any affiliated money from recommending any of the equipment. It's just it's our job to do the due diligence and make sure that we put forward to any products that we would recommend. So intermittent extract rate fan that goes on the roof, or on a ceiling, or on a wall, you're pretty much used to it. The example of a constant extract unit, and then there's also an example of an MVHR unit. They pretty much look like boxes. They get hidden away. So intermittent sizes, they pretty much vary depending on what you're going to put in. A constant extract unit, also depending on your flow rates, but generally I allow, say, 400 by 200 by 500, just as a sort of guide when you're doing outline design. And then for an MVHR unit, they're slightly larger, which I allow for about a meter tall, 600 deep, and a meter wide. Bearing in mind, the units will be smaller than this. It's just as a sort of spatial allowance. So a ventilation example of an MVHR unit, because this is the key one that I would like to push and recommend people to install on all new homes. So I've given some examples of their installation. So the first one is with a silencer. So in some instances you might want silencers put onto your MVHR units. They're called noise attenuators as well. If you are in any doubt, please ask the manufacturer, and they can recommend if you need one or not. They are very honest in terms of if you go to a reputable, go directly to the manufacturer. It's in their interest to make sure the installation is the most efficient in terms of cost as well as installation thing. But if in doubt, please ensure that they do the calculations. And then there's the MVHR unit without the silencer, located in a cupboard. And then there's the MVHR unit located in a roof space. I would recommend it to be located in a cupboard, so do the manufacturers, purely because this is a unit that needs to be maintained. They will have to have the filters changed periodically throughout a year, depending on your environment. Most likely it's probably about once a year, it needs cleaning. If that's up in the space, in your roof space, it's likely that you won't do this, or it could be relatively dangerous, as in, you know, you'll fill your roof with, like everybody, pretty much junk. It's just being realistic, putting it in a very easy, accessible place. So what are the ducting methods? There are two main ducting methods. There's the branch, and then there's the radial. The branch method is pretty much what has been used for years, and it's used pretty much on all commercial installations. The radial is starting to become more and more popular, particularly for south builds, literally because it's easier to, people consider it as easier to install, quicker to install, and easier to balance. Here or there, both systems work if installed correctly. If you install any other systems incorrectly, they do not work great. My personal preference is a branch system. I believe that it is easy, provides a better install for long-term longevity. And also a radial system can actually physically cost more in terms of capital cost, but you save your money on the installation because it is quicker to install, but it's depending on the size of the building. If you've got a huge house, a radial system will look like a spaghetti maze if installed incorrectly. And again, then the branch also has its merits as well, is if it's installed correctly, it can look a lot better in terms of how the airflow moves around the building. But it pretty much is down to sort of personal preference and your confidence of your installer. If you want to do it yourself, both systems are relatively simple to get your head around. It's not rocket science. So. And then also please use the manufacturer to do any form of commissioning, because that commissioning is very, very complicated, and they can help you understand how to do it the best, and it really should be installed by a registered installer as well. So I would not really recommend doing it yourself anyways. So here's some ducting examples from the US catalogue, which shows how the traditional system works, and then also shows you how the radial system works. The biggest thing with the radial system is you need to find a suitable space for manifolds. So generally these should be installed in a central location where you can branch out like a spider's web from a central place. If you have the manifold in the bottom left-hand corner of a home, you've got to branch all the way over to the other side, which doesn't really make a really efficient installation. The biggest thing to note with either of those is just to make sure that you keep the supply and exhaust ducts far enough apart. So what types of ducts are there on the market? So there is the rectangle PVC duct, which is very common doing the branch method. The rigid cylindrical duct, which is not really that often used because it requires a relatively large ceiling void to install, but it is sometimes better, particularly if you're changing directions in lots of directions. It makes the installation a little bit easier. And then there's the flexible cylindrical. So with a lot of people still use flexi duct, and it is important that you should be noted that they are limited to 300 mil per leg under building regulations, even though that people still install it, which technically is not compliant with building regulations, and the way you're meant to support them is very stringent, but again, that's more often than not does not get installed correctly. I would advise, and most manufacturers would advise, never to use flexible duct unless it's for the final sort of jointing from the main ductwork to the mechanical device. But if in doubt, please contact the manufacturer and ask them what their recommendation is. And then there's the semi-rigid cylindrical duct, which is the one that is typically used for residential radial systems. They typically come in red or blue, and it's quite useful to color code them depending on if they're supply or extract ducts, but it's not essential. So what sort of voids should you allow? This is a sort of voids that you should allow for if you're using PVC ductwork. The most common sizes are 220 by 90 and 110 by 54. Duct sizing. So in this chart I've provided a very quick lookup table for what we'd recommend for duct sizes based on the flow rate. So each room will have a flow rate requirement. So for instance, a toilet needs 8 liters per second, sorry, a bathroom needs 8 liters per second, a WC needs at least 6 liters per second, and a kitchen needs at least 13 liters per second. But again, going back onto what's your minimum supply rate, it will depend on what your extract rate is, because you want to have a balance. So if you say, hypothetically say, have 50 liters of supply air required, you need to extract 50 liters per second. So you need to work that out first. So that leads me on to what sort of terminal types do you have in domestic market. Generally, more often than not, it looks like a valve. It's just an air terminal that is round, cylindrical, and you can either adjust the valve to balance it at the point of where it is, or back at the manifold location. This is another example of a valve in the radial system where I talked about having two pipes. This shows you that it has two connection points for the radial duct to connect into it. And then some manufacturers offer a grill system. So in certain instances where you don't want anything installed in the ceiling void, you can put a grill at high level in the wall, or it can actually be used at the ceiling. But please contact the manufacturer for their recommendations on how that gets put in. The biggest thing to note is the location of air grills and air valves. That normally is causes the limits it determines your clear void depth in your space. Manufacturers generally ask for a minimum of 160 millimeters to install, but preferably around about 200. This allows for the grill, for the valve, and then the plenum that fits on top, and then allows for the connection into the plenum. But again, please ask the manufacturer, because each valve is different and will require different requirements. But that's the biggest thing to watch out for, is that a lot more often than not there isn't enough ceiling void at the beginning, and it's just to agree locations and stuff like that. So what other grills are there externally? So there's a wall grill. So they normally extend, it just looks like a plastic square. There's an air brick or a double air brick, which effectively you remove a brick from the side of your wall and replace it with a ventilation air brick. And then there are roof cows, which literally the ventilation pop up into the roof and then terminate via a roof cow. One of the key things to remember is that you need at least 90% free area of the connecting duct to comply with building regulations. This sometimes is often missed and causes a lot of noise and can cause a lot more resistance in the system than it needs to be. Again, manufacturers should be able to recommend you a correct size. And in either case, all of these duct supply and extract grills need to be at least 300 mm apart when installed. I would recommend them slightly wider than that, if possible, just to avoid any sort of cross contamination. So for instance, you have the supply extracting air, you don't want the supply air sucking that straight back into your building, completely defeating the object of the game. Noise and noise attenuation in a home. So one of the biggest problems probably with an MVHR unit or any ventilation systems is that because it's constantly running, you have a constant noise. It doesn't, if you hear a ventilation system, it has not been designed correctly. So the idea is to design it so it becomes unaudible for the human ear. So you do this by either oversizing the ventilation unit or sizing it correctly, and placing it in positions that you don't get breakout noise, or you provide inline silencers which attenuate the noise down to an acceptable level. Noise is measured in decibels, but the key one to look at is the NR level. The NR, because all your ears hear sound at different frequencies, at different levels, and perceive it all differently. So the NR level tries to put this into context by using logarithmic curves. The NR level for a home or in sort of bedroom should be around about 30, and in other areas it could be have a higher NR level. But if in doubt, please speak to the manufacturer. They will be able to advise on the unit, what sort of silencers you need, and also comment on the location of it. It is much better to be able to put in the silencers and size it correctly, rather than trying to do this after it's been installed and complain about the noise. It is much better to actually install it correctly in the first instance, and it will be so much cheaper. And it makes a much better environment, because no one wants to live in a noisy environment. So what other ductwork accessories you need to consider when you're designing it? You need insulated ductwork. Any ducts going out to atmosphere, so that's the unit, from the unit to the external wall. If they're in the cold space, they need to be insulated. Any ductwork in a cold space needs to be also insulated. We would recommend that the ductwork connecting the unit and to the outside to be insulated throughout. in terms of fire compartmentation, so you'll have compartments within your space that will be rated. If you plug a hole through it and you don't put any compartmentation in around the ventilation unit, when there is a fire, the fire can spread to the other side via the duct, so that these units will then compress the duct and stop the fire going from one side to another into another compartment. You need to also think about condensation, because you've got moist air being extracted from a space, so you need to allow for a condensation trap, and then also you need to have condensation waterless traps on any MVHR unit, because they do generate a level of or at least condensation builds up in the unit, so they do need a drain. If you don't have a drain nearby, this can be called a pumped condensate can be installed. Again, speak to the manufacturer. What other alternatives, options do you have with MVHR? Well, one of the main reasons people put in MVHR is to make sure you have good air quality. So and also it helps with external noise. So if you're living on a very busy road, you don't need to use your windows. You can also bring in air from a different source. So if you have, you might have a wall, a very busy road one side of your building and a very quiet area on the other side, so you can bring your supply air from that. Or you can also introduce filters as well. So you can there are filters that filter out NO2 levels. There are filters that will filter out particulates as well. So if you are particularly worried about certain things, you can filter them out. I wouldn't recommend them as a default. I would only recommend it if you are living in areas that are highly polluted, or if you're particularly sensitive. There are other areas, filters in the system, like new areas provide a return air grill filter. Technically, a system should be designed to be able to be cleaned. More often than not, this actually gets ignored, but this is building regulation, so technically you should be allowing some form of cleaning through the system. You can get valves with filters on the return air grill, which helps eliminate this problem, and you just change the air grill filter. So what sort of controls do you want for your new MVHR units or any form of ventilation? So typically your ventilation unit will be put onto trickle mode. So it will be constantly providing supply and extract to the space up until the point you want to use it in the kitchen or in the bathroom. So in a kitchen, we would recommend putting a boost button in there, so you manually boost it up when you need it. So it takes the ventilation for the whole house up to its boost condition. And then other manufacturers recommend to put most of these units will have integral humidistats, which will automatically boost it. But if you've got a large enough space, the air would actually, if you're only having one shower, the humidistat won't actually pick this up. So they either recommend either a room, having a room stat, or that can be connected to a light switch. So you can, when you turn on the light switch, the MVHR unit will boost up as well. I would also recommend, depending on how you're using your living spaces, I would recommend at least one CO2 sensor in the space, because that will guarantee that if any CO2 does get built up, the unit will then put into boost mode, and then it will then supply more fresh air to your space, diluting the CO2. I appreciate a lot of manufacturers and people don't do this. This is more of a commercial installation, very common in meeting rooms and office spaces. The reason is because humans will actually sit in spaces with a higher CO2 level than actually in a walled space. It's been proven that they would actually open the window as soon as it gets a little bit hot, but they would sit in a CO2 space without even noticing it. So they'll start to feel a bit groggy, a bit tired, and without even knowing. So by putting a CO2 sensor, it alleviates this problem. It monitors the condition of the air, and then it will ramp up and down your unit to suit. So hypothetically, if it never goes above the CO2 minimum levels, then that's fine. But that's what we're trying to aim for, is a better, healthier environment, and you do that like you would on a radiator, you have a thermostat. There's no real reason why you shouldn't have an indoor air quality sensor to monitor your indoor air quality, and that's what the ventilation system is there for, is to improve your indoor air quality. So hopefully they will become the norm in the future, but up until then I'd still recommend it. I hope you found this video useful. If you have, please click subscribe. If you have any questions, please leave a comment below, or feel free to visit us on our websites, send us an email, or even give us a ring. I'm more than happy to run through anything that we've discussed in this video. Again, if you're going to design a home, please design a healthy home. Thank you.